Mentioned we will talk about the selection criteria in this video and somewhat the summary of the whole part 1, which is the whole PDF all the way. Alright, but I don't know whether is it a full summary or not. But over here, let's take a look. Alright, it's a selection criteria, and it says that the common choice for the matrices, the thermoset matrix, right, is polyester, epoxies, and phenolics. Why? Polyester itself, alright, about it, your polyester bag, your recycle bag, these are all polyesters, alright, and it's relatively cheap. It depends on the types of polyester being used. There's some expensive also, like for your clothes or whatever. Somewhat is quite cheap, quite more expensive, but for the general purpose, the polyester is quite a good choice because it's cheap. For epoxies, most probably it's because of the surface finish is uh, is shiny, and most better is that it has higher strength and it is good to adhere to fibers, alright, than polyesters. So adhere means that it can stick well to fibers, which is good, right? Because you can create a better connections between your fibers, because you're talking about your matrix, your matrix and your fibers. So if your fibers and matrix are stick together very well, then the strength itself can increase quite significantly. Alright, the next question we will ask is that why don't you use the gel coat? Alright, gel coat over here, it is not, because of the difference in curing chemistry, it is not possible to achieve a chemical bond between epoxies and polyester gel coat. And what am I talking? If the gel coat and epoxies are two different things, alright, although they can give good surface finishes, but they are both in different genre, alright, so, or different categories. So gel coat is gel coat, epoxy is epoxies, alright. So epoxies most probably are being applied for polyester purposes, because once you have polyester, epoxies is somewhat adhering to polyesters, alright, and it's mainly, if I were to read, alright, somebody actually hit his ship, alright, his yacht or whatever, and actually the fiberglass actually broke and things like that. So, or in other words, the surface has been scratched. So there is different ways to repair the thing. And after reading a lot of things, realize that epoxy is something that is good for repairing. Alright, so this is why epoxy is always used also for repairing and surface finish and things like that. And then phenolics is mostly on doors, on your foyer doors. Alright, these are all your phenolics somewhat materials. Alright, because it's a good fire resistance. Alright, so this is why they often use the phenolics, and I think it also is quite a good cost efficient material, I believe. Alright, so over here the selection criteria, after I venture into all this, the selection criteria is talking about stress and strain limits. Alright, one of it is stress and strain limits, meaning what type of matrix do you want, or because mainly based on what type of stress and strain is the material being subjected to. So you need to know first what is the material type of stress and strain environment. Alright, if the stress is above certain amount of stress, then you have to require a certain material that can withstand that particular stress, or if not you will fail and things like that. So you have to take note of this selection criteria and know how to articulate with it. And heat distortion temperature is that the temperature at which a polymer or plastic sample deforms under a specific load. Alright, so due to a certain temperature, alright, when will it deform? So you have to know under what temperature will it deform. Alright, will it slightly deform the shapes and things like that. So you have to know this thing. Shrinkage, as you know, I've been discussing along. So polyesters has shrinkage, and then epoxies also have shrinkage and things like that. So you have to know the shrinkage. When you design, you also have to take in the consideration of shrinkage. After you because you heat it up, you expand. After you cool it down, you shrink. So this is why it has a shrinkage volume. Alright, and adhesion to fibers, because your matrix and fibers have to mix together. So this is your matrix, so you have to put in your fibers over here, right? So therefore, if you have good adhesions with matrix and fibers, then you have a stronger bonds. Alright, so you have a better strength. Alright, So this is why epoxies is a good materials for polyesters, because polyester yeah lor. And then fire resist, and the rest I think is shelf life and storage, talking about more on the pre-preg. Alright, storage most probably, because it can be stored in a certain places where it is cool, alright, things like that. And shelf life, because it is partially cured, it's not fully cured. Alright, so for pre-preg it's not fully cured. Alright, and therefore it has limited shelf life, but it has good strength and things like that, so I'll not go into details of that already. But at least you get to know a few stuff of selection criterias for your matrix. And what is COSHH? So we are talking about safe handling and processing, safety regulations. You're going to talk about control of substances hazardous to health. So this is the full thing. Alright, and it comes from the UK. Alright, so this is one of the UK health regulation system, right? Because we are studying in UK, so maybe this is why it's COSHH. Yeah. Therefore, let's come back to the summary. I mean, not come back, but rather than let's come to the summary of this whole PDF. Alright, this whole thing now. Ta-da! Okay, so I think you can read yourself because it's quite straightforward. The fibers can be woven into fabrics. Like you have your threads, you can be woven into your cloth. Alright, so you sew into different shapes and become a cloth. Things, it's the same thing. Alright, so once you do that, you have different weave patterns, or you can weave it in different patterns, and different patterns will give you different strength. Alright, and yeah, and matrix material, or in commercial name called the resin, is a maintain structural integrity, alright, by bonding the reinforcement fibers. Alright, so the matrix is ductile, while the fibers is stiff. Remember this. And this part over here, you can read it up. I think a possible question is that what are problems do you face as a designer? So you have to have between customers' requirements and the need of the fabricator in terms of cost. So if the customer wants this, but however the fabricator cannot do it or requires more time and effort, this will increase your cost. So you have to maintain in between all these things. So you have to have a balance all over. And therefore this is it for the whole part 1 basic stuff. Alright, so I believe the part 2 will be more tough. Alright, so see you soon.